Thanks to everyone for coming. My name is Jakub, and I will be talking about covering your legacy tests, legacy code with Pester tests. Oh, that wasn't a great start. So who am I? I'm Jakub Jareš. I'm owner of the Pester project and the current main maintainer of the project. I'm a Microsoft MVP. I'm also a developer writing in C#, F#, and Golang. You can follow me on Twitter under @nohvnd, or you can follow the Pester Twitter, which is Pester, which is also me, but under a different handle. If you have questions, send me a message on my email, or you can send me a DM on my personal account, because my DMs on Twitter are also open. So if you have questions afterwards, if you have questions in the future, if you just want to chat, just reach out. It's no problem. I'm also very frequently in the Slack channel on PowerShell Slack, in the testing channel on PowerShell Slack, so we can get in touch in there as well. Before we start, I would like to ask you to take some photos and put them on Twitter, because I usually don't have any photos from my talks, which really sucks, and I cannot take them myself. So you can hashtag them with PSDayUK, and you can also tag me with @nohvnd. I have some stickers for Pester, so if you want some, there are some on the tables, and I also have many more on myself. So if you want to just chat and grab some stickers, then bump into me into the corridor. I will be here for the whole day, and we can talk about what you're doing with Pester, what the future of Pester will be, and so on. So a lot of interesting topics I think we can find. So what is this talk about? So I have few talks. One of them is Introduction to Pester. Another one is Pester internals and custom assertions and so on. But I don't have a talk where I practically look at how to test stuff, and this should be it. So this should give you a starting point where you grab your current code base and you apply some patterns to it, and you cover it with tests. So that way, you can become the driver of the change in your team. You can build a pipeline, you can add Pester tests, you can test Pester the rest of your team, and you can become the one person that pushes the tests, and you will build a better working environment for yourself. But it's really difficult when just watching a talk that just gives you the introduction to the syntax, and it doesn't give you any practical examples, which I think is missing. So that's why I'm trying to do this talk. Because for me, it took, 5 to 6 years to feel comfortable like writing tests every day, even in different languages. So hopefully this will enable you to bootstrap your knowledge and just grab some code and just cover it with tests and have some green, nice tests in your build pipeline. So how do we identify what to test? So first, find the parts of the code that are giving you most of the problems. So you probably have some ticketing system, maybe Jira, maybe something, maybe just someone is always complaining about like this script not working, or maybe you see something that is just not optimal. And what's the best way to do it? Just grab that piece of code and try to cover it with tests. But don't go too far. So don't think, okay, this needs to be covered 100%. That's not the point. The point is to give you some way of identifying problems. And if the problems will start reoccurring, you should get some failing tests. So you will get some feedback from the test, and the feedback will be accurate. If you just go 100% testing, you just put so many unit tests on your code, you will spend so much time doing this, and then maybe you don't get any benefit. And this is connected to being the driver of the change in your team. Because if you try this and you just tell everyone, okay, let's just spend 1 week covering this code with tests, and then you get no benefits in the end, that really sucks. How do you explain that to your manager? Like, we just spent 1 week doing something that didn't give us any benefits. It's even maybe making the development more and more involved, because then you have to maintain the tests and you have to maintain the code. So try to find places where you can do something that covers a lot, but is not very brittle. And repeatedly check if you're getting any benefits. So if you have an issue and you have a test that should be addressing that issue, why didn't that test fail? And so, for example, for me, an example from real life would be, we had this project recently where we were writing a web server with web application in Angular, it doesn't really matter, and then we were covering it with end-to-end test, because that what the customer wanted. They wanted to have end-to-end tests written in Selenium. And so we spent a lot of time doing this, and we were tagging our HTMLs and so on, and identifying them and writing the tests. And in the end, we spent a lot of time fixing those tests every commit. Every commit, something broke. The test took like 30 minutes every time you had to run the build. And we were never identifying new issues. It was just the same tests failing and failing. And there were no issues coming from the customers saying, oh, the login doesn't work, because it worked. It was just one item moving from like one place to the other. And the testing framework, maybe we did it wrong, but we didn't know any better. So we were getting a lot of problems from our builds, but we weren't getting any issues from the customers. And so it clearly didn't bring any benefits. And so one day I was kind of fed up with it, and I just commented out that line in the build, and nobody noticed for the next like 3 months. And then I told them one day, like when they were asking, oh, why are not the E2E tests failing anymore? I was like, yeah, I commented out that line 3 months ago, and now we can focus on the other things. And then we saw, okay, but there were no issues coming from this side in the meantime, so we just kept it that way and deleted the code base. Well, the E2E tests, not the rest. And I can compare that to unit tests on my assert module, which is trying to provide better assertions for Pester. There I have about 1,200 tests, I think. And I only work on this project occasionally, but it has a lot of edge cases. So every time I come back to the project, I need to remember, what did I do in this case, and what did I do in that case? And is it still working? And then I add another edge case where, I don't know, I'm just adding like sub-expression around one variable, and it just changes everything, how the thing is handled, and so on. So that's not something that you keep in your mind, that's what you keep in your tests. And so it helps me every 3 months to go there, run the test, see they're still green, add test for the bug that I'm trying to solve, and then forget about it for the next 2 or 3 months. And so this clearly gives me a lot of benefit, a lot of feedback, and helps me to develop this solution, because otherwise I wouldn't be able to. I cannot possibly do 1,000 tests every time I'm trying to release. So that's why I write it in Pester. So this is where I'm done with my slides, and now we just go with demos, because I just like pain. No, because this is supposed to be practical. So if you've ever been to a talk where there is demos, the demos always fail. So bear with me. If you see me making a stupid mistake, then please tell me. Is the code big enough for everyone? Yeah? People in the back, can you nod? Great. So let's just try it. So the first pattern is the most simple one, where we have just a simple function. This function really doesn't do much. I will just always run my setup on the top, so I get to the correct state and the correct folder. And then I have this function which converts a string into base 64 encoding of the string. What is base 64? That doesn't really matter. It's just calling some internal functions, or not internal, some functions from the .NET framework, and just encoding that string. And so if I bring it to the scope, I define it. Normally this function would of course reside in a separate file, and I would .source it into this script. But just to keep the demo succinct and most of the code on the screen, I want to show it this way. So I bring it to the scope, and now I start testing it. So the test here is super simple. I just write a describe. So describe is a block that contains another test, and we usually call it by the name of the function that we are testing. And then we have the test itself. So the test is represented by this it block, and it has some name that describes what should happen, and then we have the code where we repeat the same values as from here. So if I run it now, it passes and everything is great. So we just gave one example of how our code should work. So this is a function that we already have, and we can look at the function and we can see that it's kind of a pure function. So a pure function would be a function that just takes some input and returns some output, but there is nothing in the middle that would change how the function would work based on some other criteria rather than the input. So the input is dependent on the output and the other way around, but we don't see anything like getDate or getRandom or getComputer or whatever inside of this function. So the output is really, really dependent on the input. And I'm calling it a pure function, but it's not a pure function at all, but just bear with me. We will just call this type of function that just takes input and gives output a pure function or a pure-ish function. And so I gave a single example, and there are multiple aspects that we can look at. So in here, I have this expected string, but how do I get this expected string? So what did I do here is that I go to a converter online, and I just converted this string to the base 64 encoding. But what if it gave me some other results? So what if I expected, I don't know, this is probably not even valid. Let's just copy it here. So what if the online tool gave me this and I get a failing test? So what do I do now? Do I grab the output that the function gave me, or do I go and correct the function? So in this case, I would go and grab the output that the function gave me. Well, I know it's correct now, but if the function gave me a different result, maybe let's do it the other way around. So this would be the correct one, and then I would do just plus dd. Okay, so now the function is giving me an incorrect result, but I should still grab that result and put it into my tests. Because what I'm trying to do here is I'm trying to describe what is happening inside of the program for real and not what should be happening if the function was correct. Because my aim here is not now to fix the bugs. My aim is to formalize how it works right now and what the function actually does, instead of mixing two things together, which would be fixing bugs and like covering the legacy code with tests. But let's revert back. Run it again. Okay, now it's working again. So now we have a single test. We have a single example for our function. So now if we wanted to add more examples, what we could do is that we just copy this, add more examples. So I will just change this and run it again. And it gives me one failing test, so I can copy this value because that's what the function produces. Put it in here and put it in here. Let's just copy that as well. Yay, live coding, I love that. And then we run it and we have two examples. But we just repeated a lot of code. So this is a super simple test, which has us just 3 lines, and I could even inline the variables. It could be just a single line of a test. But we are still copying some code. We still need to make sure that this string that doesn't really mean anything for the rest of the test, because if I change it, it will still pass, is the same as this string, and then it doesn't really scale well. So in this case, we should really prefer using test cases instead of copying the code around. So test cases are representation of a data-driven test. And how we would do that in Pester is that we would add a test cases variable, test cases parameter. And here I'm using the array with the add symbol, because that allows me to put it on the next line. So then I have a nicer formatting of the test cases. And then I will just define a hash table that will be passed to the script. And so I say the value. I would normally maybe call input, but it will become a variable in the function, and calling a variable input doesn't really work that well in PowerShell. So I'm sticking with value. So the value would be this one, PSDayUK. I'm just refactoring my test to be nicer. And then I have expected, and the expected thing is this one. So I can remove this variable. I can remove this one, call it value. And now I need to somehow get those things, those keys into the test. So what I do is that I define a param block, and I define parameters for the script block that are named the same way as the keys in the test cases. So that would be value and expected. And now we still have this here. So what I can do is that I use expansions. So I will just denote that with those pointy brackets and put the names of the keys in there. You don't really have to care about the case. I usually do lowercase. So I would do value. Oh, I did. Thank you. And expected. And now if I run this test, I should really keep eye on what's happening, because I want this test to be green, because we are just refactoring the code. It should do exactly the same thing as before. And it does. But now we have a data-driven test, so we can just duplicate this one and just take those examples and put them here. And then we should be able to run both of them from the same place. So this might look a bit tedious and a bit stupid, but if you really stick with this kind of process and you every time set up your tests in a way that they use test cases, then someone who comes to your code base and tries to add more examples, for example, as you're finding bugs, will have really easy time just adding stuff, because then you can just go here and then just duplicate this and then maybe, I don't know, try with emojis or whatever. And so what are we expecting for that? I don't know. Let the function describe it. Yeah, and so if you want to cover edge cases and stuff like this, then the person that will be coming after you will have very easy time adding the stuff, because you already paved the way. It's also a good example to add like comments to every item here if you are describing something special. So you can either do that by just putting normal comments up here, or what you can do is that you specify maybe a because, or maybe just a description, because you don't have to use all the values that are in the hash table. So you can write whatever you want and then just consume just the value and expect it. Or you can specify a because and also pass it in, and then pass it maybe here to this should. So I wrote the same thing here with multiple examples, just slightly different formatting. Still gives me the same result. Now, testing a function is not just about the functional requirements. You can also test multiple things like non-functional requirements, like do we have help defined for all the parameters? Is this one exported from the module? Is this parameter really mandatory if we want it to be mandatory? Because PowerShell is super self-descriptive, and then you can just use commandlets to grab all of this kinds of info. So for example here, I'm trying to describe if it has a mandatory parameter value. And we will use this example to write our own assertion. So here I'm just grabbing the command object of the convert to base 64, and then I'm inspecting on that object the parameters hash table, getting the value key from it that gives me the descriptor object of that parameter. I check the attributes on that, and if it's mandatory, it will give me true. So I just check here for should be true. Now you can see I have this because string here, and that's very useful if you're doing something with should be true. So if I run it like this, it passes, but if it would fail, so if I redefine this function and just make it non-mandatory, then I will get very generic, come on, huge font. Oh, that was too much. I get very generic message that says, expected true but got false. Okay, that's awesome. Then I get the line that's underneath it that just says mandatory should be true. That's kind of descriptive, but doesn't really tell me exactly what happened. So I can provide this because string that will put the message in the middle of the expected something, comma, then because string, and then but. So then when it fails on my build server, or when I get failure in 20 times, I get different messages that describe exactly what happened, and I can use it to locate the error directly, or maybe describe it much better for myself what happened. It's also a very useful technique when you have some preconditions. So sometimes you're writing a test and you want to check, like, I'm reaching to a database and I'm deleting a user. So if I call this delete and then I check that the user is not in the database, then you get true. But if the user is not in the database in the first place and the delete function doesn't do anything, then you also get true. So you need to go and you need to check, okay, I have at least one user with this name in the database, then I try to delete him, and then he's not there anymore. So for that case, you can use a should condition that you would put at the start of the test. And there it's nice to have a because string where you can say, this is here because this is a precondition for the test. So your setup is incorrect. It's not that your function is incorrect, it's just the setup. And that will help you a bit. Okay, I'm spending way too much time on this example. So adding your own assertions, I have a full talk on this. It's recorded from PSConf EU this year, so you can go there and you can watch it and get some techniques. But here I just want to show that if you have some reoccurring things that you want to test, you can create your own assertion operator and check it like within your problem of the domain. So for example, you are checking often that an IP goes into some range, or you are checking that something took less than some time. So you can always write the 3 lines of code that you need for it, or you can just encapsulate it into a single should operator and then use like should be faster than this threshold maybe. So here I'm using the thing for having a mandatory parameter because that's my previous example. And so I'm calling this function that's coming from Pester, which is called @should_operator or @assertion_operator. They are both the same, just aliased. And I'm giving it a script block that has actual value, the parameter name, negate, and because. And then I'm checking if the actual value is null or the actual value is not a command object, then it doesn't really make sense to make this test because the only thing I can do it at is the command info that gives me the description of the function. Then I check the is mandatory, which is the same thing as we had in the test, just with this parameter name specified from the outside. And then there's this negate, which represents the dash not in your assertion. So if you would say should dash not have mandatory parameter, you want to invert the result. So here, if it's not negated and it's mandatory, then we succeed and we need to produce this object. And in the same case, if it's negated and the parameter is in fact not mandatory, then we also succeed. In the negative case, we produce again a result object that has succeeded set to false, and we provide a failure message that will describe what happened. You can see that I'm not supporting the because string here, even though I have the parameter, but it would be just somewhere here, just a sub-expression with if because is defined, then just expand this message. Pretty easy to do. You can see all of that in the other talk. But I just want to point out that it's possible. And so if we define this, the should operator should be registered with the should keyword. And now we can write the test in a way more succinct way. Okay, yeah, because I commented it out before, right? So it is working. Fix this one, bring it to scope. Fix this one. And we have our own assertion operator that just enables us to write the test easily. Now, this assertion operator is actually built in some of the latest versions of Pester, so it would look like this. I think Oliver Lipkau implemented it, if I'm not mistaken. So you could instead use just should have parameter mandatory value, and it has a lot of variations that you can use. But you can also write your own, or the point is you can write your own when you need it to make a more succinct and nicer syntax. Anyway, so that's a simple function. Most of your code probably won't be simple functions because the person who wrote it, maybe you before, didn't really have testing in mind. So you will probably get a mix of weird patterns, gets and sets in one function, and so on. So here I have a function that calls another function internally. And so it's just integrating with the Pokemon API and grabbing the Pokemons from there using invoke web request. And the Pokemon API is a bit fiddly, and it has a weird format that you need to comply with. So the Pokemon name needs to be lowercase. It has to have the slash in the end, something that we are not that used to when we are integrating with like ASP.NET Core Server or something. And then we are invoking web request. We are using the get method, using the URI from the that we just formatted, convert the response from JSON, and then just grabbing some items from that response. So pretty simple function. But the thing about this function is that it integrates with an external system. So if Poke API was paid, we wouldn't want to pay every time we are trying to test if this URI formatting works correctly. So if it costed 20 cents and we just used it 1,000 times every day, then we would have our manager on our back asking why, or maybe why. So what we want to do is that we want to take the system and we want to split it into multiple parts based on some seams. So for me, the good seam is some commandlet that someone else provides. Typically Microsoft, but it can be coming from someone else, maybe from an open source project. It's just something that you didn't write yourself, so you probably don't need to test it. So in this case, what I can do is that I use mocking, and mocking is a way of defining your own behavior for functions that you want to replace. So in this case, I'm creating one mock, which I call a default mock because it doesn't have any parameter filter. And this is here just to prevent me from actually calling the invoke web request in any case. So whatever I specify, it will just fall back into this mock of invoke web request and just do nothing. Then I have the actual mock that does the work for me and helps me test. And this one has a parameter filter that filters for this pokeapi.co. And this is a useful way of specifying a mock if you have multiple calls within the function that you want to mock in different ways. And then I have this mock with block where I specify a script block, and inside of it I'm grabbing the content from this JSON file, which I have, which I grabbed on last year somewhere. So I just call the real API, get the result, and save it into JSON. And this is a great way of giving your tests some way of integrating with external system in a static way, because it gives you a very accurate picture of what the actual API would do, but it doesn't incur any cost on you. So you can call this 1,000,000 times now, and the only thing that you will pay for is the CPU in your computer, or maybe your own electricity, but not the costs of the actual API, if there were some. And you don't get rate limited and so on. So saving stuff into JSON or into CLI XML and using them later is a great way of stabilizing some external dependency that you don't really want to integrate with because it doesn't make sense for your test. Then I just grab this output and I return it back to the function. So what I'm doing here is that I also define this expected object which describes how the response should look like, and then I'm testing against that. So let's just try to run this and see if it fails. And it passes, which is great. So here I'm just grabbing the content. I'm not actually calling any API. I'm just faking it. But I can test potentially if the result is correct, if the processing inside of the get Pokemon function is correct. I can check all of the things that the object gives me, and I can do that in two different ways. So this would be the way that's kind of native to Pester, where you just write multiple assertions, one after each other. But the downside of this is that the first assertion to fail will fail the whole test. So if the name is not correct, for example, it's going to be, what, a Charmander? Then the only info from the test we will get is that the name is not right. And then we go and fix it, and then if this type is also incorrect, then we get another fail, and so on. And so that's not very convenient, because then you have to rerun the tests and figure out what exactly is happening. And so a better way that I would propose to do is to use my assert module, where you have this assert equivalent function that takes two objects and just recursively compares everything. So let's just comment this out. And now if we run this, it will tell us the actual difference between those objects. So it says, those are the objects that I got. The difference here is that the expected property name with value Charmander wasn't equivalent to the actual value because we got Pikachu. And what it also can do is that if you have multiple properties, for example, this color isn't on the response, you will get appropriate info as well. So it tells you expected it to have property color, but the other object doesn't have it. And so this works recursively over collections and collections of objects, and it gives you a lot of output. So, and it also gives you like the complete info in just one fail. So that way, if it fails on your build server, you get everything that's wrong about the object, not just the first thing. On the other hand, I think this is still a pretty nice pattern. So in Pester version 5, we are working on making it possible to chain the assertions together. So it would look just like this, but if you didn't specify here error action stop, it would fail in all of the assertions and just log the errors and then fail the test in the end. So you would get a similar info to this one. You would get like 4 fails inside of this test, and you can keep writing your test with multiple assertions this way and get complete info on the failure as well. So for me, that's very, very practical and very nice. Next slide. Was that it? Oh yeah, I just wanted to mention that then the next logical step in this testing would be to grab this formatting, replace it with a function, because you already have tests, so you have nothing to worry about. And then you can just factor this simple function out, and then you can test this easily with just unit tests and make sure that you really have the slide in the end and that you really have the name to lower invariant without adding any like JSON and loading and so on, because the ultimate idea is to split it into small functions where some of them are pure and some of them are integrating those pure functions into more complex behaviors. Okay, let's load this again. So those were just 2 patterns. There are about 4 patterns that I could identify in tests. So the one that we already covered with the pure-ish function is that we have some input and we have some output. And so we test it exactly as you saw before. We have some test cases, we provide the input and the expected output, and we are done. So then in the future, we are just adding multiple new examples to check the function, but it's just the matter of the input and the output. Then we would have input to mock. So we have some input from a function, and yeah, just don't mind this function. I wanted to give this demo first on Windows, but then last I switched to Mac, so I'm missing some of the commandlets, but I'm sticking with a common theme of renaming computer, which is exactly what you cannot do on macOS. So yay for me. But I have this function setStandardizedComputerName, which is pretty stupid. It just uppercases the name and then calls renameComputer. So the name is the input to our function, and then we have this renameComputer, which is provided by Microsoft and possibly tested and possibly used by thousands of people every day. So we can believe it works. So the only thing that remains for us to test is that we call it correctly. So that's where mock comes in. So we define a mock. You can see this is a default mock, so it will be called every time because it doesn't have any parameter filter. Then we invoke this setStandardizedComputerName, and we call it with the name myPC. And then I'm using assertMock call to make sure that we called renameComputer, and then we can filter here on the parameter filter. So unlike in the previous example, where we had the parameter filter on the mock because we wanted to be able to provide multiple different behaviors, in this case, we don't really care about the behavior because we are not returning anything. We are just getting some data from the input, and the mock is in the end. So the mock will be just checked with assertMock called, but it doesn't really do anything. The single case in which it would do anything is if then this expected some value. So this would be like value that we need to grab, and then it would say if value equals 1, then throw, or if value equals null. Yeah, right. Not the best way to put it, but if we needed to return something, then we would have to specify the body here. But in this case, typically we don't. So typically we just use this for replacing the set kind of commandlets, the ones that actually do the work, that don't query the external systems. Then we have next pattern where we have mock to output. So we are using the mock as the source of our data. And those we typically use for the get type of commandlets. So for example, in this case, we have this function, which is really awesome, that just formats a date in a specific format. And we use this getDate to produce the data. But getDate is really difficult to test with because getDate just changes all the time, right, based on the time. And so if I want to test with it without using any mock, then what do I provide here? So what do I say in here? How do I test it? So what I could do is that I grab date twice, and then I try to compare it because it will be probably on the same day. So we have maybe some edge case, like exactly when we are going over midnight, it will start failing. But it would ultimately mean that we are duplicating some of the logic into our tests, some of the logic that should be in the production code. So a better way is to replace the getDate with a stable version because we only care about the format and we can test that against any value. And so in here, I'm just having a mock and I'm providing the min value of date time, which is 0110. No, sorry, it's 0010101. So that's pretty easy, but runtime error. You sure? Requires mock behavior. What am I doing? Oh, I just mistyped. Demos. Now it works. So this is an easy way of producing min value, but you probably won't start with this. What you would start with this is just doing getDate. And then what happens is that you are just calling your mock from the mock. So it just gets into an infinite loop. I'm feeling lucky, so I will just try it and it will just get stuck until the stack is filled. And that's, I don't know, like some 9,000 iterations in this version of PowerShell. So that's not gonna work. So what you need to do is you need to understand a bit of how mock works, and mock defines aliases for getDate when it tries to shadow the function. So what I can do is that I can use my awesome PowerShell skills and just say command and do get command getDate. And then the crucial part is to say that the command type should be commandlet. So I know that getDate is a commandlet, and this way I'm able to grab the original object of getDate, and then I can simply invoke it using this ampersand operator. So command day 1 month 1 year one. Okay, not defined again. And so now it works again. So if you have some more complex commandlet that enables you to kind of stabilize it by itself, like get date by providing the day, month, and year, or get random by providing the seed, or something like that, then you can do it this way, and this way you can call the original commandlet from the mock. And then we have mock to mock, where we usually do something like get something, update something, and then stop something or set something in the end. So here I have a pretty stupid function that just grabs all PowerShell processes and stops them. And I'm trying to test it, so I need to do two things. One is that I assert mock that the stop process was called, but then I also need to provide some data from the get process. And this is not a very good test, but it works, but it's not in the best way. But if you need to do something like that, then you have to provide at least two mocks. So one that provides the data, so the pipeline is fed with some data, and then the other one that replaces the behavior. So it's the combination of the two previous things, and it's just occasionally useful. Now, similar to that, in the previous one, we were just returning a simple simple PowerShell object because the get process and stop process are bound together by the input from pipeline by variable name. Is that what it's called? So the name of this on this object will be put onto the name parameter on the next thing. But sometimes we need to do something like this, where we have this get VMI object, again, missing commandlet for me on macOS. But I'm, again, trying to set this standardized computer name, but this time I'm trying to do it via VMI. So the way I would do it via VMI is that I would grab this Win32 computer system class, and I would call this rename method on it. So I know that I just need to provide the name, and then I want some return code to be equal to true, so I can indicate back to the caller that it was correct. So the problem here is that I get this object from the getVMI object, and I call this method on it. And again, I believe that this method will work, so I only want to validate that I'm calling rename with the correct parameters. But how do I do it when it's on an object? So what I can do is that I create a script block that will represent the rename function. It will take the same amount of parameters as the other function, and in this case I call it name, the same way as on the VMI rename method. And then I have a reference to this object because I will be using this as a script method to shadow the actual rename function. So this will refer to the actual object to which this script block is bound. And I will use this __ name to save the value from the call. And then I will return 1 just to be able to pass this condition and return true back to the caller. And so then in my test, I will take the script block, I will create a PS custom object that would represent the class object that the getVMI would return to me, because we don't have any strong typing checks there, so the consumer doesn't really care. The only thing he cares about is that you have a rename method that's on that object, and then we attach it using addMember script method and providing this script block back to it. So that way everything ties together. The __ name will be modified by the script block when we execute it. And then we create a mock that will just return this placeholder object to the caller. So we can grab it, call the rename, we save what is the name that he called it with, and because we have reference to the same object, we can check on it if it was the correct call. So I call the method, then I grab the placeholder object and check the internal __ name, which saved the name that we provided, and check if it was actually my PC. So it's kind of weird to figure it out this way, but it's quite practical when you already have this in your code, because still you're just trying to cover your legacy code with tests without modifying it, because that brings chance of breaking the actual code. Next pattern. Oh, this one is fun. So what happens from time to time is that you have to integrate with binary commandlets. Yeah, no. Reset. 5 minutes? You sure? I still have like half an hour. Is that right? Oh, cool. Oh. I was scared. Sorry, we're just chatting about how much time I have, and I'm at example 4, I think, out of 10. So 5 minutes kind of surprised me. So what I'm doing here is that I'm importing this binary module that I just called computer commands, and it's coming from my just local build, because I built it with, not Visual Studio, with Rider over Mono, but doesn't matter. So I import it to the scope. I grab the commands that I defined there. It just has get a computer and set a computer. And so if I grab a computer that is called my computer, I can look at the object and I can check what type it has. So the type of the returned object is local computer. And I can see that it's not a public type and it's not an abstract type. And this sometimes happens when you get something that is just not published from the assembly. And it also means that you cannot kind of replace it because it's not public and it's not abstract. But to start investigating this, you might want to go and look at the assembly, because your ultimate goal then is to write something like this. So you have get a computer that is piped into update computer, which is your function, and then it's piped back into set a computer, which is like both get a computer and set a computer are commandlets that you got from the external sources, but the update computer is yours and you want to integrate well with the other two. So typically this happens with like VMware commandlets and so on, so that's why I'm using this computer team and types. But luckily in this case, if we first look at this assembly and location that we get from the get type, we can figure out from where the commandlet was loaded. And if we look at, I think, get help of set a computer, we can see that the input object of this takes something that has type computer. So the set commandlet is usually the place where you start investigating this, because the set commandlets take parameters, and the parameters describe much better what types they use instead of the output that is usually just object. So I'm just gonna grab that and just go into Windows here. I have a copy of this assembly in here because this awesome tool, which is called JetBrains.peek, that you can download for free, is a great decompiler that would help you easily figure out what's happening inside of the assembly and how you can fake the type that the commandlet is giving you. So here I have this close. I have this set a computer command, and I said I want to start investigating from the set a computer. And so we can see that it's inheriting from commandlet. That's not very interesting, but we can see this input object parameter has this type computer, which is what the command itself will want to consume and what the update computer should produce. So if we look at this type, we can see that itself, it's an interface, and that's great. And it's also a public interface, because in order for us to be able to mock it successfully in PowerShell, we want this to be either an interface or an abstract class, because those are two types that are abstract in C#, and we can implement them ourselves, and then every consumer that takes either that interface or that abstract class doesn't really care about how we implemented it or where the type behind it is coming from because it's hidden behind this abstraction. That's the whole point of having abstractions in the end. And so I can see that this interface is present here, is public, and so now I can start looking for stuff that would help me do this much easier. So what I'm trying to get is a public type that has maybe very simple constructor and implements this interface. So I can either click through all the types in the assembly, but if you have thousands of them, that doesn't really work. So open it, where is it? So I can click here through the menu and I can see that there is inheritors, which I can open and I can get all the types that inherit from this interface, and it also works across multiple assemblies if you're looking for stuff. And I can see that the only inheritor here is the local computer, which is the item that we got in the first place. So, and it's an internal class, so it's not published, and it would be a bit difficult to instantiate it because we would have to use reflection and so on. So we don't want to do that. Plus, one thing that would also probably happen here in production code would be that they would probably check if the name is populated, if it has some size, if the description has some size, maybe some other properties, and it would be just complicated, and it would add like the internal rules from the commandlet into your code. So a much easier way for us is to just grab this computer interface and just implement it ourselves, because then we can provide whatever we want for the values, and we can get the instance very easily. And we can luckily do that very easily in PowerShell as well. So yeah, I just wanted to show that this will fail because the type is not public. And so I cannot even instantiate the local computer if I wanted without writing reflection. So I just opt for implementing the type myself. It's super easy, just some basic C#. What we do is that we use add type, we reference the assembly from which we want to grab the interface, and then we have type definition, which is just this here string. So we say we are using the namespace that's coming from this assembly. If we didn't have this in place, then we would just have to say computer commands.computer, so it's fully qualified. And this is the class that we are implementing so we can instantiate it. And then we just take both properties and just make them automatic. So we don't do anything special. We don't create any constructor with any constraints. We are just looking for extremely basic class that we can instantiate immediately. And so then, if I would write the test for it, I would have this new object, test computer, which would instantiate a type. That's old syntax. I could just do the normal type and colon a new. That would give me the object, and then I can specify whatever name I want, and then I can use it as an input object for the computer, because this already has the computer interface type. And so the input object will not reject it, and we can all process it correctly and just get an object that we created ourselves. Bit complicated, but very useful when you have to deal with it. No, this break. Why? Ooh, it works. What a surprise. I think I lost all of you, right now. Well, if you have any question afterwards or you want to go around this with me, just experiment with .peak. It's an awesome tool. Even if you do C# development, it's an awesome tool. It can have like a symbol server and helps you so much debug stuff. And learn some basics of C# and it will just bring you forward, especially if you have to deal with this kind of stuff, like having binary commandlets that you have to test against. But the rest, here we were super lucky because the commandlets published their published types as abstractions, so either as interfaces or abstract classes, but that's not very common with binary modules. Usually they will use some type that will be public but will have some super complicated constructor, and because the type itself is not an abstraction, you cannot replace it with anything else. Or static methods will be used a lot that are not really possible to replace with mocks in PowerShell, unfortunately. So if we deal with .NET types, usually what you should avoid is calling the static methods directly. So for example, instead of doing date time now, it's better if you wrap it into your function. I don't know why I called the function itself getDate, but rather use getDate than datetime now. Or if you have any other static method, just wrap it into a function. That way you give Pester a chance to mock that, and it will be much more native to PowerShell, and the syntax will probably look better as well. Same thing with, this was a property. Same thing with methods on types, like if you're calling NewGUID, I'd rather use NewGUID. If you're calling anything else from any other class, rather just put it into a function and use that function instead, because you can write documentation for it and you can mock it afterwards. Where are we? Now for something totally different. So sometimes I need to ship some scripts and I want them to be as simple as possible so the people can consume them directly. And the easiest way is still to just give them a script and just tell them, yeah, run it. But then the script has to execute itself, and then it's really difficult to test because every time you .source it, it will execute, and it will try to do something like, I don't know, clean up your domain or build your server or whatever, and you want to prevent this. So I came up with this simple idea because Pester is using aliases for mocks, and if you follow this simple practice of putting your entry point into a function, like this, so I have this main function that is entry point to my script, and then I'm just calling in here on the bottom, passing the parameters. So this gives you two advantages. The call is at the bottom and the main stuff is on the top, so you can immediately see what you will be doing. And also, you can then test it with Pester. So what you can do is that when you .source the script, you either write it yourself, or you use this import script module that I wrote. So basically the gist of it is that we define the entry point, the name of the entry point, and then we trick PowerShell into resolving our alias first before the main function. So when we .source the script, everything will be imported, and the alias will be invoked, which will have a placeholder function behind it that does nothing, and then we remove the alias, so when we call main again, it will just work and call the actual main function. So here I'm just doing the same thing manually. What is it? So just defining the entry point where the script is, defining a function in a non-automatic way that just says this is a placeholder for this entry point. Then I set this alias pointing to a placeholder function. That doesn't really matter, but it's this function that I defined up here. And then I .source the original script, which would normally call the main function that would invoke what's inside of the script, but it doesn't happen because we resolve to our placeholder function based on the alias exactly when you are doing mocks. And this is still the placeholder because we still have the alias in place. But if we remove the alias and we call the function again, it gives us the original thing. So this put us into a state where we can import the script and we can also test the main function as well. So if you want to automate this, you will have a very hard time because of how the session states and scoping works in PowerShell. Because then when you take this import script and you define the stuff inside of it, and you will try to export the function from this function, then it will be imported inside of the function. When the function finishes, the function will die and go away, and you will have alias that points to nowhere and so on. So it's difficult, but it's doable. You can look at the import script in my sources if you want. But then it's just a matter of easily automating this call by calling import script, pointing it to the script, giving it the entry point, which is the name of your function, and maybe some arguments. In this version, I just went for like a simple providing the arguments like this with a string. So let's just try that. And it passes again. So the idea here is just, for me, still like giving people scripts and not modules and not telling them this is how you import it and this is how you execute it and this is how you do this and that is a good way of shipping stuff, especially in like build kind of scenario where you have CI and you just have one build script that you probably won't test it, but you don't want to make it a module and import it from another script that you probably should test as well. So this is kind of the last mile problem where you sometimes end up with a script that's self-contained and you need to test it somehow. What's the time? Yeah, still some 15 minutes. Then testing in module scope. If you have any experience with Pester, you probably already know this, but I want to point out one difference. So here I import this module called M1. M1 is simple, it just has this getGreeting, which calls internal function getGreetingText, and it only exports this getGreeting function. So we have getGreetingText that's internal to the module, but we still want to test it somehow because it's super simple to test it and it's just a matter of testing a pure function. So why not? So here, I run this and this is how I would do it. So I can test getGreeting, of course, because that one is exported. There's something wrong. This one should fail. Why you don't fail? See? It was imported, maybe. So here I'm testing the getGreeting because that one is easy to test. It is exported, but then I'm trying to test the getGreetingText, but it's not exported, so I need a way to get it from the inside of the module. And one way to do it is to use this in-module scope construct and provide it with a module name. The module name is M1, same as the module that I'm using. And this way, I'm running inside of the scope of the module. So I have all the internal functions available. I can just mock them directly, and then I can just test the getGreeting directly with the replacement of the getGreetingText. And so that's one way to do it, but the bad thing about this is that I'm running inside of the module. So all the variables, all the stuff is available to me, and I cannot really easily test just the public API of the module. So the better way to do this is to have a mock and give it this module name M1, which will inject the mock inside of the module, but your code itself will just stay outside of the module. So if I execute this, or if I would execute this, it would call the getGreetings that is publicly available. It would run in your session state where the script is, not inside of the module. So we can prove that by just writing host and just showing in which execution context we are running, which is a simple way of determining where we are at the moment. And so in the first test, where we are mocking the internal stuff through the in-module scope, we can see that we are in module M1. But in the last test, where we are just using the module name on the mock, we are in no module, and that means we are in the user script. So if you want to just replace some internal functionality of a module and you want to still test the public API, this is a much better pattern than using in-module scope. Then one of the few last kind of silly examples, but I found it kind of interesting because I saw a question about it few days ago on the PowerShell Slack. I'm still not sure about if it's practical or not, but I just want to throw it out there for people to see, and maybe someone will come up with a good idea how to use it. So I have this module M. I'm just re-importing it here. It's in memory module, and it defines function A that calls this write debug. And this write debug does quite a lot of stuff. I do similar stuff inside of Pester, where I need to write debug messages to the screen when the debug flag is enabled. But sometimes the debug messages take kind of a long time to generate. And so what I need to do is that I wrap them into an if, because I want to avoid all the execution of this code. So if I, for example, didn't have this if, then figuring out this summary just to be expanded into this string, and then the string is never reported because the flag for the write log is never specified, is just time that I will spend computing, and it will slow down the whole framework just to be able to write debug messages one time. And so instead, I want this computation to happen only when write debug is specified. So that's why I have this if, which is external to both of those functions. And so now I want to ensure that this get readable summary, which is pretty expensive, is only called when write debug is set to true, which from the code we can see, but how do we confirm it? So let's try to run this one. It passes. But if I comment out this if, and it will actually invoke the get readable summary, we should get a fail. Yeah, and the fail is just by simply, we are making a mock, and because this script block is kind of counterintuitively to me, running in the execution context where the code is executing, we have access to all the stuff that's above, because the variables are inherited to the child functions. And so we can just directly check if this value is what we expect it to be, and if it's not, then we just throw. So maybe if there is like a complicated if that you want to check from a function that's inside of it, this might be a way to do it, just like to avoid refactoring the code and taking the function outside. I'm not really sure. It's just kind of weird and kind of interesting at the same time. I'm not really sure about the usability, but if someone comes up with something, here it is. And then lastly, some stuff that you shouldn't do. So the first thing is you shouldn't really create stateful mocks. If you are doing some integration testing, it can be very tempting to write some complicated logic inside of the mock, start doing some counting, some ifs, because you have this, and then you call the same function again, and then you're just trying to figure out what's happening. Instead, just split it into two different functions, or two different tests, and provide it with the correct state. So if you are trying the first example, do it in the first example. If you're trying to test the other example, try the other example, but don't put them in the same place into the same mock, because then your test code is becoming complex and you cannot be really sure about the state and so on. Plus, if you take this and you would switch the test cases, it will start failing. And that's not what you want to do, to have your test cases dependent on each other. Because there is this principle that's called first, so your test should be fast, independent, repeatable, ST, who knows? Doesn't matter. And the last one is timely. I just cannot come up with the S. So don't make your tests dependent on each other, depending on some global state. Just reset it every time with before all if you want. So sometimes take your test and just switch the order, see if it starts failing. If it does, you're doing something wrong. The next one is the last one, and that's just don't use should not throw. There's probably like one single case where I saw legitimate use of should not throw. But apart from that, every line in your code is should not throw. If the code throws, the test will fail. So don't state it again and again. If you have should not throw, you probably have unfinished test. So why would you test that close task doesn't fail? check instead that get task will get the task and it will be closed. And that's much better test. And if you don't have get task a commandlet for it, then maybe something is wrong, because how do you figure out if the task is closed or not? You should call get task. So every should not throw, it just seems like unfinished test, and I wouldn't use it in your code. Good, let's go back to the presentation. So demo time finished without many hiccups, luckily. Is there still time for some questions? There should be like 4.5 minutes. So any questions? If not, there's my contact info. You can ping me on DMs. You can send me an email. You can just talk with me here in the corridor. I have stickers, and I'm not afraid to give them to you. That's been there for a long time. Oh yeah. So the question is the in-module scope versus the module name in the mock, how long it has been in the framework, and it has been in the framework for a long time. It's just the in-module scope is much easier to use, and it has its legitimate use when you are testing the internal functions of the module, and you just don't care. Because I think when I was describing that test case, I was talking about it a bit incorrectly. If you're trying to replace the internal function of a module with a behavior, this is where this applies. If you're trying to test an internal function of the module, then you wouldn't replace it with mock. You would use in-module scope, so you can reach inside of the module, and you can test the actual internal functions. But I think I described it incorrectly before. So the use case here is that you are replacing the functionality of an internal function, and you are calling it through a public function. So in that case, the module name is preferable instead of the in-module scope. Anyone else? Okay, go on. Okay. So the question is for resources of learning Pester, right? So on YouTube, I have this playlist where, okay, this one. So this is a playlist. I will put it in the resources. There are multiple talks. It starts with the introduction to Pester that I gave in Singapore, but it's not just my talks. There are great talks by other speakers, and I try to order them in a way to give you like 101, 201, and then progress based on the experience and how hardcore it is. And it just has a lot of info, and hopefully it will help you. Also, there are a lot of resources in our wiki page on GitHub. If you just go to Pester, there is this very simple example of getting planets, but it has also this annotated version which describes everything that's happening inside of this, and yeah, how everything is bound together, some exercises and so on, so that could also help you start with this. Then there are PS cones. They are not specifically aimed at learning Pester, but they are aimed at learning PowerShell. But playing around with the idea and maybe finding some bugs in that might also help you learn a lot. And then you can also choose some of the bugs maybe in the framework and just try using it and try developing it and become part of the project and join those contributors that are here. More questions? I don't see anyone, so in that case, thank you very much for listening.